Hello guys, we'll be looking at the Program 7 of Data Structures Laboratory, which is about the single linked list. Here we'll be performing 4 operations mainly, that is the front insert, rear insert, front delete, rear delete, and we'll be performing the display function. So first of all, we'll be needing 2 header files, stdio.h and standardlibrary.h, and a variable called count will be initialized to 0. Since the single linked list, a linked list will be holding the elements of different data types, we'll be using a structure definition for it. So struct node, it'll have USN, name, program, sem, phone number, because it will be storing the student details. So a single linked list will have 2 parts. One is the info part, the other one is the link part. So the link part is defined as struct node star link, which is a self-referential structure because it will be pointing to the same structure of the same type. Then the node parts info will be looking like this. That is, it will have USN, name, program, sem, and phone number. So this is about the structure definition, and don't forget to terminate the structure definition. After which you have a variable that will be struct node start, which will be initialized to null. So there's a variable that you'll need to keep in track of the starting of the node of the linked list. Since linked list is not a continuous memory location, it will be like the elements will be stored in different memory locations. You need a start variable so that you will know at what location the linked list has started. So the start variable has been declared, and it is of the type struct node, and it is a pointer, so it is start, then it will be initialized to null. Then you have a function struct node star prepare new node, that is to prepare a new node. So whatever new node will be prepared from this function. That is, you will declare a variable called new, struct node star new, then you'll initialize the data part to be 0. Then you'll use the malloc dynamic memory allocation to allocate the memory for the new variable, that is struct node star malloc size of struct node, which will be allocating memory for the variable new. Then you'll ask to enter the details of the student, that is USN, name, program, sem, and phone number. Then the scanf will have %s, %s, and %s, and %d for the sem, and %s for phone number, since you have declared it using the character data type. Then you'll have new of USN. So whatever the details are being asked from this, it will be stored in new of USN, new of name, new of program. Here you've used ampersand because for sem you'll be using the int data type, so that is why you'll have a ampersand for this. All others will be just new of, that is this, it is a pointer operator. Then you have new of link, which is initialized to null. That is, whatever new node that has been created, this link part, this is the link part. So this link part will be initialized to null. Then we'll be returning whatever the new node that has been created. So you will return new. So this is about the prepare new node function. Then you have front insert. So in front insert, what happens is, first we'll be declaring struct node star n. This is another variable n. Then you'll call the prepare new node function, which will create a new node, that is n, and its link part is null, that will be stored in n. So this is the first step, after which you'll be checking if start equals to null. That is, the start variable holds the first node of the linked list. So if it itself is pointing to null, since the art is pointing to null, that means there is no new node in the linked list. Therefore, what you can do is, whatever new node that you declare, that is in n, can be put into start. So it will be pointing, start will be pointing here. Since it is pointing to null, you can point the new node, whatever you have created, to start will be pointing to the new node that is being created. So start equals to n. So whatever is there in n will be given to start. Else, if there is another a list of linked list or a linked list before you insert at the front, so this is front insertion. What you can do is, firstly, the n is the new node that has been created. So n of link part, this link part, you'll be initializing to null. But if you make it pointing to start, that is n of link is pointing to start, it will point to here. So once it points to here, a link is established, after which you can start cannot be pointing to somewhere else in the linked list, so it should point to the first node. Therefore start pointing here will be disabled and it will start pointing to n, that is because it is the first node that is before the before the node that was actually present, because this is friend insertion. Then you'll be incrementing the count, then you'll be returning whatever has been stored in the start. Then come into the display. First of all, you'll declare a variable struct_start_ptr where you'll initialize the ptr with start, because start variable cannot be used to like traverse the whole linked list. Instead, you'll use a ptr variable so that you can use this ptr variable to traverse the linked list. So firstly, we'll check if start equals to null. That means if start is pointing to any other linked list, or if it is pointing to null. If it is pointing to null, then the list is empty. You'll be printing list is empty. This is a display function, so it will be displaying the list is empty. Else, if there are linked list that if start is not equal to null, then first of all you'll be printing the number of nodes is %d, that is count. This is why you'll be incrementing the count here once you have done the insertion. While insertion you'll be incrementing the count, and while in deletion you'll be decrementing the count so that you can print the number of nodes. So firstly you'll be printing the USN name, Program-7 and phone number. So for displaying, what you do is, first of all, ptr is not, while ptr not equal to null, see, ptr is a variable that is used to traverse the linked list. So this is the linked list, an array of linked list. It will traverse until ptr becomes null, that is the link part becomes null. It will go on ptr equals to ptr of link. So ptr of link, so this link part will have the address of this, so it will point here. Then this ptr will have address of this variable, of this node, so it will be pointing here. So this goes on until ptr is not equal to null. So what it does here is you will be printing the ptr of USN, ptr of name, ptr of program. Since you have given whatever is there in start to ptr, you can use the ptr variable to display whatever is there in USN name, Program-7 and phone number. So after which you'll be returning the start variable. Now coming to rare insert, in rare insert we'll be declaring two variables, star n and star ptr. N equals to prepare node, so you'll be creating a new node and storing it in n. So this is the new node and its link part will be null. Then coming firstly, we'll check if start equals to null, that is if start is pointing to null, that means whatever is there in n will be stored in start. So this is same as that of the front insert. Coming to else part, that is the rare insert part, you can't be inserting directly from the rare because this is not a doubly linked list. Since you have only linked to the, you have traversing option of only to forward linked list, you can't be going directly to the last linked list. So that is why you'll be traversing the linked list. For that you can't be traversing to start, that is why you'll make ptr the whatever is there in start to point to give it to ptr. After which you'll check ptr of link not equal to, until then ptr equals to ptr of link. This is ptr initially because start is pointing here, so this will be ptr. After which ptr of link will have the address of this linked list, so it will come here. After which it will check ptr of link is not equal to null, but here it is equal to null. So what happens is ptr of link, whatever ptr of link that is null will be initialized to n. So the n will be whatever ptr of link will be pointing to n. So a link is established, after which you can the whatever new node that has been created has been inserted at the rare end. So after which you'll be incrementing the count variable, then you'll be returning start. This is about the rare insert. After which front delete will be initializing a variable called ptr struct node star ptr. After which you'll be checking if start equals to null, that is if there is no linked list at all. So we'll be printing list is empty. After which else part, firstly you'll be initializing whatever is there in start to ptr, because here again you'll be traversing. So after which here you have to delete the first linked list. For that to happen, what you have to do is the PTR. See, this is PTR now because start is pointing to PT, like start and PTR are equal. After which PTR of link, that is, it will be pointing to this linked list. So if PTR of link part, whatever is there, this node, we only need this node. We don't need this node. That is why we'll be initializing the start with PTR of link. That is only this. So once the start is pointing to this node's connection is broken. Therefore, this whatever is there in PTR will be freed. Therefore, it is deleted. Then you'll be decrementing the count and you'll be returning the start variable. This is about the front delete. Coming to rear delete, you'll be declaring two variables, struct node star PTR and star pre-PTR. You'll be initializing PTR with start because again you'll be doing the traversing part. Firstly, you'll check if start equals to null. If that is the case, list is empty. Else if, you'll check if PTR of link part equals to null. See, since you have initialized start and PTR are equal, if by chance there is only one node, and this is nothing but both start and PTR are pointing to this node, and if this link part is equal to null, that means there is only one node in the linked list array. Therefore, what you can do is, if start is pointing to this, if you make start equals to null, that is start equals to null, that means the node is deleted. So once the node is deleted, free PTR. So this is the second case. Coming to the other else case, that is, you have a list or a array of linked list. What you can do is, firstly, until PTR of link is not equal to null, you'll be traversing PTR equals to PTR of link. So once it becomes null, before that you'll have a pre-PTR variable where you'll be storing whatever is there in PTR. So the pre-PTR, whatever is there in pre-PTR link, so pre-PTR will be it will be linking here and PTR will be linking here. So once PTR becomes null, the pre-PTR's link part will become null. So once this becomes null, the connection is broken, which means that this PTR is broken. Therefore, free PTR and it is deleted. So this is about the rear delete, and you decrement count and return start. Coming to the create function, like if you have to create a linked list array, then you'll be using this function. So struct node star create. First of all, you'll be declaring a variable n. Then you'll be initializing a variable called I equals to 0. Then you'll ask how many nodes to be inserted in the linked list. So it will be stored in a variable called n. Then you'll run a for loop for I equals to 0, I less than n, I plus plus. Whatever you'll be inserting, you'll be calling the f insert function, that is front insert function, and it will be stored in start. And you'll be returning start. This is about the single linked list different functions that you'll be using. The void main will have int ch equals to 0, that is the choice variable, and you'll be using a do while statement, that is do. Firstly create, second is f insert, third is rear insert, fourth is f delete, fifth is rear delete, and sixth is display, and seventh is exit. So you'll ask the choice printf scanf, it will be stored in ch. Then you'll use the switch statement where you'll pass the choice, and firstly the first case is create, which will be stored in start back. Then you'll have break. Then case 2 is start f insert, you'll be calling f insert function, that will be stored in start. Then rear insert, then you have front delete, then you have rear delete, then you have display function, and you close the switch statement and includes the do while statement. Here you'll be writing while choice is not equal to 7, all of this will be running. Once the choice is equal to 7, you have to exit from the program. Then you'll be closing the whole main program. So this is about the single linked list. Thank you guys.